Whether you need to manage bots, protect cloud applications at runtime, stop form jacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shift-left. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Security Weekly Unlocked will be held in person this December 5th through 8th at the Hilton Lake Buena Vista. We're excited to announce our first round of speakers: David Kennedy, Alyssa Miller, O'Shea Bowens, Marina Sivata, Patrick Coble, Chris Eng, Eric Escobar, Kevin Johnson, and Justin Kohler. Visit securityweekly.com/unlocked to register and check out our exciting lineup. If you missed any of our previously recorded webcasts or technical trainings, they are available for your viewing and listening pleasure at securityweekly.com/on-demand. Just come over to securityweekly.com. You can find all kinds of fun stuff there. You can also find our previous segment when I was stumbling over how to pronounce the word block or Bach. And John, I feel a little bit less lonely knowing that I'm not the only one making very trivial verbal typos in this sense. But help us out here with this article that you picked up about Chrome and an unfortunate typo.
Yeah, and I'm sorry you've caught my disease of constantly stumbling over words in ASW. So let's see if I can not jinx myself here this morning on that. This popped on my radar probably beginning of last week, and whatever the first headline I saw, it didn't quite have the right combination of words to catch my attention. It was talking about breaking Chrome devices, which I don't care about. But then at some point later in the week, I saw this version which I posted in our show notes, which is talking about what actually caused that bricking was a single character. And in the article, there's a link out to the actual fix on chromium-review.googlesource.com because we're not using GitHub for other reasons. But yeah, literally a single ampersand. So CC is the C++ code. They're doing an if test. If a key data has value and if the key data label is empty, but in the previous version of the code, it was a single ampersand, which for the pointy hairs and those who don't fully know, a single ampersand in most coding languages is a Boolean and. Is a Boolean and versus and is a logical and. So in other words, you want A and B, not the Boolean mix of A and B.
Bitwise, yeah.
And it's did I get it backwards?
I just wanted to throw in, the bitwise versus logic is what you're getting. Yes. But you're on a roll here. Keep going.
Cool. Yeah. So, it's funny. I actually caught one of these in a code review myself in the last week or two. Actually, wasn't a code review. I was pair coding with one of my guys, and I'm like, you need another. But it's a hard one, man, because I bet some linters would catch it or some static analyzers would catch it, but this is sort of, if you're, coding, it'd be fun to go back and see when the original code was written, if it was a late night commit. But this is such a simple thing to do. But the end result of that is one little character is now bricked. I don't know what the number is if it's in there, but probably tens, if not hundreds of thousands of devices, right? These things sort of, they sprout like weeds because they're so cheap and they're useful to a lot of people, don't get me wrong. So I see the value in them. It's not really my thing. But yeah, so that's the end of the day. it's easy for us to make a slip of the tongue on Application Security Weekly, but try not to do it in your code. How about that?
Good call. It does also call back to the idea of a little bit maybe of code comments, in the sense of what was the intention of this, code path of this if statement? Are we comparing two different states and we need both of them to be true? In other words, your logical or do we just are we trying to compare actual integers or compare values bitwise and say, are they all zeros or all ones? Which is that subtle difference you're getting to. And to your point, we talked, was it 2 episodes ago, about code comments? I don't know that code comments necessarily would have helped us here, other than explaining we want to make sure that the user, we have a data has a value and it's not empty. But before we go then do some checks on it. But in this case, you also mentioned linting. I know LLVM, for example, will do some complaints. For example, if you're doing some bitwise comparison or in an if statement, and you're not doing necessarily an equality check on it. So this can be a little bit of nothing comes for free, but it's sort of that idea of a coding pattern. Do you want to do a bitwise comparison and have an explicit equality to 0 or explicit equality to 1, for that matter? Or is it intended to be a logical comparison, and we can have our double ampersands? Or honestly, if we talk about, this was the other reason I wanted to mention your code comments. If we talk about readable code, the word "and" can get you pretty far, just in the sense of, oh, right, the word "and" is going to help me out here, and it's going to be a lot easier to understand, and hopefully a little bit harder to make that mistake. So a couple different ways you could potentially turn this into a lesson learned. But that's an unfortunate mistake.
And you're actually, and this wasn't scripted, but you're giving me a lead into something else to talk about. So the code comment, I think, was actually last week. We talked about that because I got a very impassioned response from somebody about this from down in Australia. And so go back and talk about that for a second. What the point I was trying to get across there, in case it wasn't clear, at least to some folks, and probably was my fault, was that I'm recommending people to make those code comments for both yourself and for fellow developers. I'm not so much suggesting that by you putting a comment in there in the code about what it's doing, that if you go through a third-party auditor or a security reviewer, that they're going to go, oh, he wants to do this type of thing. Because what if I put the professional code reviewer hat on? I sort of look at the comments and I laugh, right? Because half the time they're not accurate. What you'll frequently see is developers copying a block of code from one place to another and then not changing the comment, which you should be doing anyways. But so it's not so much providing guidance to security teams, it's providing guidance really to yourself or to your other poor fools, either who are working with you or who will be joining your company in 6 or 10 months. And one more point, you trigger another brain cell there around the and which is one, and this comes down to a code style thing, right? Which again, we haven't talked about that. Maybe I'll look for a code style article and a few more articles. My preference is if you're doing a Boolean comparison, bitwise comparison, not Boolean, that you would be using a all caps constant, which you are anding in on one side or the other. Because then it becomes very clear. So in other words, I don't want my constants to be lowercase. I want a constant to be clear to be as constant. And then if I'm doing some sort of bitwise thing, use that constant. And that triggered one more final, which I'll say and then shut up, which is if you're doing a large allocation of memory or something, please, for baby Jesus' sake, don't do 20 left bracket 32 to say some large amount of memory. Put it into words so I don't have to actually do some amount of math when I'm actually looking at the code later. And on that, I will give you back the conch.
I will take that shell, John, and I think that's a great setup for a segue into another article you pointed out. So here we have with Google Chrome OS a bit of a snafu that these boxes are bricked until their next. Fortunately, they will do their self updates or self reboots, so they can pick that fix up. But you have here a headline: bugs are more expensive to fix in production. Are they? Maybe not. So this is one of those, maybe this is our thought-y piece of the week. And I'm curious, why did this one, what was the brain cell that glommed onto this one?
The brain cell that glommed onto this one is, I was actually looking for the stat myself. It might have been from my most recent CNCF talk, Cloud Native Security Day talk. There was a talk I did recently where I was looking for the stat, because I think in AppSec, we quote this one all the time. And for those who aren't, in the Application Security Weekly book and that article club, someone went back and figured out they were looking for that stat also to reference it for someone else, and they realized that the publisher of that stat, which was IBM System Sciences Institute, doesn't exist. So, and this is to sort of we jumped in too quick. The stat we're talking about here, which we always refer to as a bug in production, is 100 times more expensive to fix than it is in development. So really, all the article is saying is that the guy who said that doesn't exist. So someone said that, and we now all say it, and they have some stats around from other people saying, well, maybe sort of, yeah. My gut sense is it's definitely more expensive to fix a bug in see, we did.
There it is.
Can't even
it's
speak.
Done. Bingo.
It's more expensive to fix a bug in prod than it is in dev stage. I mean, unless you are an organization that you're able to really do your releases multiple times a day, it's going to be slowing stuff down, right? You're not going to get that fixed, and it has to be prioritized. When do you fix it? Then it has to go through the QA process, and that's going to be slowing something else down. So it's got to be more expensive. If it's 100 times, I think that's the question. But so it was interesting to see this out here, and then to sort of I'll put a follow up on my previous comment. As we are a global, worldwide listened to podcast from Australia and India and all sorts of places, if I comment about baby Jesus or Jesus, I'm not trying to offend anybody. We're religion agnostic, so please take my comments with a heavy grain of salt.
But we will continue to make fun of Perl. Sorry, Perl. On that note, things not written in Perl, but that have contributed to many common weakness enumerations, I picked up the 2021 CWE Top 25. And I think, unfortunately, it doesn't look like an improper use of logical and bitwise operators makes the top 25 list. Might be something hidden in around there somewhere. But clearly, here's a list that is we've talked about in the past. And I forgot to prep our excellent AV team with a drum roll. But imagine, if you will, a drum roll as I pick out rank number 8. Thank you, John. Improper limitation of a path name to a restricted directory, which is a path traversal bug. But so this is pretty neat, and I think the broader aspect I kind of wanted to highlight around the CWE Top 25 is that we have a list of many common vulns. CWE itself and the numbers, I'm just looking around, hopefully no one hears this, but are kind of useless to anyone except for tracking statistics. So if you're trying to build out a security education program, there's no point in saying here is the CWE number, here is the CWE nomenclature, for example, necessarily. Just pick out some example bug classes like an out-of-bounds read and write and say, we want to get rid of these because we are a C++ shop, or we have a language that lends itself to these types of problems. Or we want to get rid of path traversals, so we'll build a framework or build some education around the type of attack like that. So those are some of the things that I wanted to highlight initially about this list. And there's a couple other points I'll come around to, but John, I'm not sure if you had a chance to see all of the top 25 and if you have your own favorite on this list as well.
I was eyeballing it. I'm still a big fan of null pointer dereferences. They tend to crash more than anything else, but it's one of those things where, especially for these, a good portion of this is C or C++, or it's a pointer-based list to a degree. And I think, even in Go, we can still get nil pointer references. So it's not just purely C, but that's one of those ones that some other languages are going to be a little bit better at actually catching and stopping them and the compiling and the tooling. But I still see a good number of folks making those. And I think, just go through this really quickly, right? So it's not going to be too quick. But there's a good number of them in here. Overflows, deserialization, null pointer we mentioned, memory buffer bounds. I couldn't say default permissions, but I probably could say, let me give one more. XML, yeah, entity dereference. A good number of these are pointer based in one way or another. And I'm being very loose. I recognize when I say XML dereference is a pointer thing, but work with me. It's application security. And so, but So there's some things in there which are as a class, talking about CWEs that you'd want to attack. But I think what I really liked about this is just it's in a table that I can see the top 25 in one screen and sort of eyeball it from going through 20 pages, but not so much from a 20-page point of view, but just as you look at this in a little more concise format, we can do conversations like what we just did. Interesting to see the ranking going up and down in some of these as their importance changes over the years. So yeah, it's worth about as much time as we just spent talking about it.
Well, I'm going to sneak in a little bit more time to talk about it, but I do agree with you. What I'm going to sneak in here too is I would be very curious about the age of the code that where these vulns are being found in, especially on the compiled code side of things, the C, C++. That are we just getting better at finding these now, or researchers are just getting more focused on we want to dive into this particular area of the kernel or this particular aspect of the browser, or whether it's an older version of a browser or a new one. And where I'm going with that is the idea that there's a good mix of compiled code, the out of bounds, integer overflows, etc., and the web-based code, SQL injection, RCEs, XSS is up there at number 2, as well as path traversal and CSRF. So web, and there's a lot of vulns here that are relevant to the modern web, including serverless for that matter too, as a callback to our last segment. But to finish my original thought, I would just be curious if, LLVM, and I'm sure GCC has equivalent, I just can't recall it off the top of my head, has a lot of the sanitizers, address sanitizers, undefined behavior sanitizers. And if you're compiling your code and turning those on, a lot of these should at least trigger, fingers crossed that I'm right saying this, some complaints from the compiler, or at least the compiler pointing out that says, this looks a bit wonky, this might not be right. And hopefully we can just see the tooling help us both to identify this in legacy code so we can fix it, or ideally prevent it going in the future, so that this CWE Top 25 for 2022 might have a different type of representation on it, in the sense of what might be prone within particular programming languages, or that web versus client-based or compiled types of applications.
And if I could spend to give it a few more seconds, what I was doing there as you're talking, I'm like, how about let's just look at the top 5 and sort of think about what's in that list. Mm-hmm. And as I focus down and think, I'm going to petition to change my favorite to actually be what's number 2 on this list, which I think should be number 1. So out of bounds read and write. Is that really an issue in 2021? I think that, as you mentioned, legacy issues, I think that's where that comes into me. But number 2 is actually number 2, 5, 6, 8, 23, 25, and possibly 24. In that, from the point of view, if you're actually sanitizing the input you're taking from a user, whether that's coming from a web interface or anything else, that's going to capture quite a lot of this list, right? So it'd be interesting to do a little survey here if people want to hop into Discord or YouTube or give us feedback anywhere. And don't forget, like and subscribe. But it'd be interesting to see what type of apps are our listeners writing. From the point of view is, a lot of the stuff that I've been doing the last years, besides some heavy duty back-end containery type stuff in low-level C languages, a lot of the stuff that we do really day in, day out is web interfaces, right? And APIs and stuff like that. So that's where I think people should really be focusing on the majority of the time in 2021. So it'd be interesting to see how the rest of the world thinks about that.
Would be curious, and I'll go as we continue to extend what was going to be. This is our CWE Top 25 minutes discussion now, apparently. But with cross-site scripting, that's where I go back to my old canard of use React, use the framework that just makes it hard. And even with command injection, both OS or just process, CLI commands, as well as SQL injection, most, if not all, of the modern programming languages have parameterized ways to build commands, whether it's obvious the parameterized queries in SQL, or just here is your process name and your argument list being passed on to it. So I would almost even argue that you don't have to worry as much about the input validation as you do just use the correct templated type of function. Now, obviously, there could be some nuances in there, and I'm sure our good listeners could find out some exceptions here. But I feel strongly that we have those capabilities in place. So it seems like 2, 5, 6, 25. Those are the OS, a lot of the command injection and cross-site scripting should actually just be gone away because we have the tools to get rid of them.
Yeah.
Oh, and I think you might have had another thought in there.
Oh no, you said 2526 or something. I just said hike. It's a dumb joke.
Bringing you dumb jokes and top 25 lists. One other thing I will add, I did come across, so the Google Project Zero has a website on their GitHub page for root cause analysis, zero-day RCAs. And I just wanted to highlight that as a good reference because if you're curious about actually out-of-bound writes, you can find a relatively recent one in Internet Explorer. And they have a couple other examples of use after free and a lot of these compiled types of flaws because they're looking at a lot of Chrome, a lot of browsers, a lot of OS or kernel types of 0 days. And so I just wanted to throw that out as an extra reference. Check it out in the show notes if you want to find just how to demonstrate a out-of-bounds write in 3 lines of JavaScript is pretty impressive. And it can be really good as an educational piece if you want to say, here's what's relevant, here's what modern types of flaws and attacks look like. So I'm going to put my foot down metaphorically and say, yes, let's move on from the top 25 into a real quick comment about a bug still. This was format string, which I forgot to see where the format string lists falls into the list of the CWE top 100 maybe. But we talked last episode, I forgot now, about the iPhone bug and the Wi-Fi network that could have %s, %p, %n, and so on. Someone apparently was able to turn that DOS against a device into an actual full-on code execution. So pretty cool. And I just want to highlight that as kind of an aside that bugs should be fixed, and that there's a crypto, as in cryptography, comment or tenet that attacks always get better. And in this case, an attack did get better, not in the sense of the cryptography aspect, but just the turning a DOS into a code exec. So something to be aware of, something to point out. The other thing I did want to, so we've been talking about flaws, and I'm going to use this to go and talk about one of the other types of security events that are going on within August, which is the Usenix conference. Now, this is a bit more academically oriented conference because all of the papers are written in LaTeX and 2 columns, and everybody shows off how they can do proper formatting and footnotes, which, don't get me wrong, I do appreciate footnotes. But I went through a couple of the presentations that are coming up in August, and there was one that I thought was really neat, finding bugs using your own code. And it has a bit of a clunky acronym, this detecting functionally similar yet inconsistent code. Now, the basic premise is, and I have to do my hand wave, the Kinsella-approved hand wave, because we're going to machine learning, exactly.
Yeah.
But they're mentioning, rather than saying we're going to have the magic of machine learning, we're going to train this on a massive amount of data and code out there, they're saying, look, you have your code. We're just going to train on your code. We're basically going to build the AST, that abstract syntax tree, and we're going to look for semantically and logically equivalent snippets of code and compare them and say, it looks like you have a couple of if statements. You're using the correct type of ampersands in here, or double ampersands. And it's semantically, it's working on the same types of variables. But, oh, look, you forgot to do a free on your string. So maybe there's a memory leak here. And, that's a memory leak, and that could lead to potentially a DOS, but there could lead to other types of problems. So what was really neat to me is that if we step back and say, what's the take-home message, or what could somebody do when they read through this or think about this, is not go and roll your own ML and figure this out, but in the principle of, if you had a bug bounty report come in, or you have one of your own scanners or your own AppSec team find a particular bug, are you able to describe semantically what that bug looks like within your code? And can you find similar areas where their vulnerabilities might be? So it's the idea of, rather than playing whack-a-mole with bug bounty and say, oh, we fixed that once, now we got another report, we'll fix that one, another report, we'll fix that one. You say, we got one report, is this a fundamental flaw, and are we able to search the rest of our code for this particular type of category of flaw? And to me, that's something that I think is unfortunately a little bit easier to say than do, but I think it still can be done with a team. And hopefully this type of research leads to better tools to be able to do this with a semgrep style functionality that can make our code better.
I was just about to say, somewhere the semgrep guys are raising their hands going, me, we can help.
Indeed they are.
And I haven't read this whole thing. I want to read this whole thing. It's super interesting to me. I know it's definitely a serious paper, because not just does it have the look of a paper written in LaTeX, but I also see the mention of NP complete in it, so it has to be a serious paper. But no, this is a super interesting topic, right? As you're talking, I know Golang CI, one of the linters for Go, that will catch duplicate code. I'm not sure how far away it checks. Mm-hmm. But yeah, because the problem I've run into with some projects is, you grow your team too fast, or maybe not too fast, but you grow your team. There's different people writing code. 2-3 folks implement the same thing because they can't find the other one in the code. Then when you go to try and figure out which one you want to use, back to my commenting comment, if the comments aren't accurate in saying what it actually does, you might pick the wrong one. Or maybe one was written by a senior guy, one was written by a junior guy, one has a bug, the other doesn't. It gets sort of tricky, right? So it's a fairly important thing. If you're doing sort of the modern startup mode where you have like 1 or 2 senior angels, and then it's not just a startup thing, right? Everyone does this. And then like a team of more medium and junior developers. How do you sort of really keep eyes or keep tabs on what's going on? So this should be a good read over something strongly caffeinated to keep me awake.
Indeed, good read. I appreciated too that they focused and they demonstrated the success of this, the utility of this against in this case QEMU and OpenSSL in particular, and discovered 22 new unique bugs. And just at a glance, they looked like actually meaningful bugs and useful bugs, rather than just like, oh, that's not even on a code quality aspect. That's just like yeah, sure, that should be fixed, but it's not something that gets me interested or excited. So big thumbs up to this research. Hope to see it turn into tools, because I think that would be the other thing, is that this summer comes along, we see a release of tools and presentations, and then a month later, we're on to the next big and interesting thing, and those tools and projects start to collect dust, and we don't improve the baseline of security, and that's what I would really wish to see. So I'm fanning, being a fanboy on this particular paper. We'll see what happens. The other thing I'm a fan of is Qualys has been doing a lot of really interesting work, poking at some really interesting edges and dusty code areas of the Linux kernel. In this case, they have Sequoia. And for those of you out here in California or who enjoy some redwoods, the Sequoia sempervirens, great trees. So an excellent named vulnerability for this one. But what they discovered was basically a type conversion error. So, hey, CWE top 25, here is an integer overflow. They went from size T to int, or basically unsigned to signed, and bad things happened. And once again, this was local privilege escalation, which, sorry Linux, I think local privilege escalation are possibly a dime a dozen. I'm not sure what the economics is these days, but I think the inflation is still on my side, at least in theory. But this type of type conversion, as I'm not making puns intentionally, is one of those things that compilers should be pointing out, or linters or semgrep, as we just mentioned, can find these types of patterns and hopefully go in and say, hey, I'm comparing size here. The size of this object, in this case, a path, a depth of a path or a path name, for example, or maybe it's something that could be coming across in a packet. But if this is an attacker influenceable size, that's probably something that should get more scrutiny and have a little bit of extra care into this, whether it's signed to unsigned conversion, or making sure it does a safe int, or adjusting your pattern a little bit so that when you do that signed to unsigned comparison, that you're doing it in the secure manner. Yeah,
another good Reddit from Bharat Jogi and the team over at Qualys. They keep doing this. We're going to have to turn this into a Qualys Security Weekly. And then we're going to have to charge them more for how much they are a sponsor, but lots of great stuff as usual. So, yeah, I was digging into the code on this one last week when it came out. It's one of those things. I think this hits you more in a C-like language where you really care about the size of your data structures, right? So I think that's part of which actually starts throwing you off, and as you start doing type conversion back and forth. I'm wondering, for existing packages out there, how many are actually going to be sincerely vulnerable to this? So the Linux OS is vulnerable to it. I believe they've got a video in here, right? Of the walking through the POC, or to have the code for the POC is pretty simple. Just forward down and create a bunch of directories and then bang. But for an existing, I'm familiar with one open source project that took a step back and go, okay, do we need to patch this? And the conclusion, which I think was legit, was no, it's not going to hit us. So you have to have a situation, if you don't have a shell or something on the box, where you're able to actually create that many directories. So this is a really interesting one because it's privilege escalation. It's pretty easy to execute, but still you need to be in a position where you're able to actually, even if it's imagine you have like a web call where you're creating a directory each time. So you're basically going to have to DOS the system to create enough directories in the first place to create the DOS or the permission execution. So it's an interesting one to think about. When do you actually patch something like this when do you patch something like this ASAP because it's going to be a big deal versus we're going to get to this in the next release, I think is how you'd approach it. So we're doing lots of thought pieces today, and I think this is sort of one of them in a way.
It is, and I love the direction you went there, because I would just expand that into that basic kind of bug bounty triage, if you will, or just you running a SAST or a DAS scanner for that matter, in the sense of, is there a code path to this vulnerability? Is there an executable path that's open to an attacker? And that's not clearly, we're not saying you don't need to patch it. We're just saying, when do you patch it? And that code path or that exploitability, if you can get a good sense of it, can inform that decision, especially if you're running a system that's running as root. Local privilege escalation doesn't really make a difference. As well as, too, if you're going to end up DOSing the system before you even get to that local privilege escalation, doesn't matter. You actually maybe want to start addressing that the brittleness to if it can be DOSed. So good ways to think through a vulnerability. And I guess what I'd say is this is our magic of threat modeling, the vulnerability. How much do you care right now to expend those engineering resources? Which I think we're getting close to the end of time, but I do want to hit at least on this transparency report from Twitter. And really just one single percentage that they called out is that 2.3% of their users have adopted MFA. And of that group, basically 80% of them are just using SMS to FA. So it's one of those aspects where it's really easy for us on Application Security Weekly to say, use input validation, deploy MFA, and you're done there. And then the episode's over, and we don't get to make any references to New Wave post-punk or what have you. In this case, it's great to say we have a 2FA or an MFA solution, but if nobody's using it, oops, how good is the solution? Or, we need to figure out as a security side, maybe product security or security of products, or take a product approach and say, what's the hang up here? What can be the driver to increased adoption? Because I think clearly we know that is a great way to prevent account takeovers and to minimize how many people reuse passwords and so on. But if we're only doing this work for 2% of the population of our app, clearly we have to figure out how to influence that number or set our sights elsewhere to tackle some other aspect of this. And I'm kind of running out of ideas, so that's why I'm going to have to save me here, John. What's the solution here that we can get this 2.3% to at least 2.5%?
Stop using Twitter. Okay, let's see if I can come up with a slightly better one. Yeah. And I use Twitter. I can't. No, it's I as soon as you said percentage, I knew you were going to go after that 2.3. It is what it is. And I think, to take a step back and expand, this is actually, it sounds probably sort of shocking to us, but this is the world, right? So this is, of the applications that we talk about on ASW, this is probably one of the more commonly used by end users and consumers, right? So the question comes down to, how do you get that group of folks? We're not talking about enterprises or banks or,
Right.
a lot of stuff we generally talk about or we think our listenership is around, but this is that general endpoint. How do you get someone who wants to post the latest thing about, pick your controversial subject, how about we just say that? And does that particular person and their mindset want to go and pull out their factor to be able to, not so much to tweet, I get that, but even just to log in and register the app on their phone or their whatever. So I think that's the sort of state of the problem, right? It's not so much what Twitter's doing or how they're doing it, and that's why they allow you to use SMS, because they're trying to make it as easy as possible. But even at that point, people are going to be hesitant. So we've improved. They increased their usership by 10%, almost 9.1%. But how do we really get that group of folks to embrace basic identity verification? How about that?
Yeah, and not controversial, but definitely Team Free Britney. So there's my Twitter topic for the day. But I say, yeah, to your point, we can say zero trust is a great thing. Adopt zero trust. Throw out FIDO hardware keys, YubiKeys, etc. to all of your developers. Boom, your problems are done. Well, that's great from the supply chain perspective, from your SDLC perspective, but hopefully your application security threat modeling and your purview, your charter, is still for your users and their data, whether they are being potentially exposed to fraud because you can do money movement over a particular application, whether they're being exposed to abuse and picking up on the controversial topic of the day, such as, is Perl readable by anybody but the person who wrote it? Those are the things that you're getting to. So, yeah,
and
yeah, go ahead.
A real quick one on this. I mean, while we sort of snark and haha funny and Twitter and all that.
Yes.
Somebody was sentenced, I can't remember who he is or where it was or the details, so I'm going to forget it, but at a glossy high level, somebody was sentenced to prison in last week for murdering someone for their Twitter handle that they wanted.
Yeah. So
this is still sort of a deal, right? And I'm not saying that 2FA would stop that. Might have slowed it down, I guess, but for some things, even, and we're not talking about going out towards some of the uprisings we've had around the world, which Twitter has, I don't want to say empowered, but help people find each other and create that community. Just the basic thing that some dude had a Twitter name that was cool and short, or I don't know what the name was, but someone else wanted it, and they shot the poor bastard because of it. So these are important things to some people. So how do we, it's even the most simple things. What I'm basically saying is, even the most simple things, if we take a step back and think about how we threat model it, there's still a lot of value, a lot of importance around some of these.
Absolutely great point about that. It's the threat modeling aspect, because who would have predicted that the 2-letter and 3-letter Twitter handles are that valuable, especially to influencers or just gamers or other groups who want to have want to highlight or show off a particularly vanity handle, if you will. Same you'll see within squatting on a lot of different any type of new social media enterprise that pops up. That's a great topic. We'll have to figure out how to bring in some more threat modeling on product abuse. It's one of those topics that I've tried to pick up in 2021 and bring in a couple articles kicking off from January and a couple other times. So I think there's some product abuse that we'll bring on later. I did have one final article. Don't know that we have too much time to talk about it. It was more about, it's a little bit of marketing fluff, so that's also why we don't need to talk about it in too much detail. But it was about, from Google Cloud and their CISO, Phil Venables, who we highlighted a article from him about complexity and security and the role of design in making those two actually work better together. But as a follow-up to our last week's discussion about clouds and risk, and availability, this is just a couple food for thought on compliance in the cloud, telemetry in the cloud, and basically one of the things that I'll just kind of highlight is that reducing the cost of controls. So just making it easier so security can be a natural, easy a cost-effective step for dev teams to roll out. And we could potentially, to tie back into just our previous discussion there, the idea that SSO for enterprises shouldn't be extraordinarily, an added expense for your SaaS. There's a whole SSO.tax website out there tracking this type of aspect. So those are my thoughts on the Final Cloud article. John, any parting words either on that or anything else about what we talked about today?
Not so much on that, unfortunately. It's paywalled, and I love my friends at CSO, and I've both written for them and done talks with them, but your site's paywalled, guys. And I should have a login, but I actually can't find one right now. But what I would recommend to folks, we were talking about serverless earlier. If folks want to get involved in that, Cloud Native Security is doing a white paper around serverless security. So either hit me up on one of the socials or go check out the CNCF Slack. Love to have more input on that. They're doing a ton of great stuff. I've been talking a lot about CNCF recently, Apache, all sorts of different open source things out there. Help out where you can and sort of help make all of us a little bit better.
Help us improve those security baselines. Yeah, hop onto Discord and ping John. He'll be happy to connect you with all the great information, just as we are always happy to connect you with AppSec information on a weekly basis. Want to thank everybody for listening. Want to thank John once again for joining me on this news segment, as well as our talk with Imperva and Peter talking about serverless. We're going to take a week break now, so we'll see you next week on Application Security Weekly.